Hello, I am Chanyak Jung from Dongguk University DTM Lab. The paper I will review today is Will AI Solve the Patent Classification Problem? Here is the bibliographic information of the paper. The paper was registered in the journal World Patent Information in 2024. The keywords are as follows. The table of content process as follows. Introduction. Patent classification, as it is commonly known, is an essential and strict text for better organization, indexing, search, and retrieval of patent application documents, and is performed by professional patent examiner in patent office around the world, and it is a more difficult task than one might think. The need for classification to take into account technological developments and the increasing volume of patent documents has been evident since the early days of the USPTO, and the first patent classification system, USPC, was introduced in 1860. Also, various patent classification systems have been developed in each country. All of these systems share the common goal of retrieving technical information contained in patent documents. They were developed based on different philosophies, hopefully different classification logic and structure, and as a result have different characteristics. Eventually, the need for uniformity, universality, and harmonization between the various systems used by the various patent offices around the world arose, which led to the creation of the IPC, and in the pursuit of uniformity and consistency, the EPO and the USPTO decided to develop a common patent classification species system. However, despite the use of the same classification system and the establishment of policy by WIPO, the assignment of codes to the same technical feature and technique was not consistent between patent examiners of between different patent offices. The causes of these discrepancies can be diverse, including human, institutional, social, or technological factors. In addition, as the number of patent applications increases and the need for improved performance arises, patent offices are beginning to introduce automated system for patent classification, with the EPO in particular testing several automated systems including. Similar automated systems are also being introduced by other patent offices. An ideal patent classification system should be completely consistent, but in reality this is difficult and is influenced by several factors. First, there is the inherent complexity of the inventions. This is because inventions can span more than one field, and the technical concept being complicated or becoming increasingly complex. All of these factors increase the difficulty of identifying the essential technical picture of a new invention. Second, there is the length of the patent document. Patent document, a large document consisting of many different types of elements, including text, diagram that support the text. Patent text is structured into several fields, annotated by metadata and structured as follows. Furthermore, the length of patent document is increasing over time. Here is the terminology used in patent document. The language and terminology used in patent document differ from technical paper or general technical communication. The applicant who writes a patent document is essentially communicating technical information, but is constrained by the need to disclose it accurately and the same time to maximize the scope of legal protection. This is two conflicting goals, namely accurate disclosure and maximum scope, make patent document unique among technical literature. This leads to the use of many vague, general, and inclusive terms in order to avoid knowing the scope of legal protection, and the more innovative technologies tend to be vaguely defined as its existing technologies. The use of such general and vague terms make understanding an already complex invention difficult and creates additional difficulties in the subsequent language modeling process. Next comes the complexity of the classification system. Patent classification systems are massively hierarchical with thousands of codes, and additionally it is common for a single IPC CPC code to cover multiple technical areas. Finally, classification systems must change dynamically to keep up with technological development, with new codes being created or existing codes being modified and merged. These changes further add to the inherent complexity of the classification system. Finally, there is the lack of standardization. Each patent classification system follows different principles, rules, and approaches and has different classification methods. Thus, the IPC and the main patent classification system are primarily categorized by function, but in some areas the criteria applied are mixed, which can lead to inconsistencies. Furthermore, the patent classification system contains numerous expansion and libels, and the national and international classification system used by some patent office do not necessarily follow the same rules. Thus, also WIPO set guidelines for the IPC classification. There is little standardization in the way countries and patent offices apply the IPC. The next factor is human-related factor. First, despite the training effort and experience exchange between patent office, the standard, the search and interpretation behavior of patent examiner to the influence of examiner personality, patent examiner are human and are naturally influenced to some extent by their own expertise, capability, and experience. Accordingly, classification work can be influenced by the work style and personality of patent examiners. Next is the lack of familiarity. IPH is an international classification system used by many patent offices, but problems arise in patent offices such as the USPTO that use their own classification system that is not based on the IPC. Also, patent examiner with a small number of specialized personnel or expert in a specific technical field and are responsible for classifying patent documents within a small set of IPC code, but in small patent office with limited specialized personnel, examiner often have to classify patent applications that cover a relatively broad technical area compared to large patent office. Since these patent examiners still have to use a more detailed classification system, there is a great chance of error. Let come heterogeneity in classification practice, where each patent office has its own practice for assigning IP code to patent document, which may influence the code ultimately selected. This means the different patent office may assign different numbers of code for the same invention, with some office tending to assign more code than others. Figure 2 shows that these differences are gradually converging, but the USPTO constantly applies more IP code to patent document than the EPO and WIPO. Only due to the high productivity demand, patent examiners have a limited amount of time to devote to each patent application and its classification, which is determined by the workload of the patent office in question. Generally, patent offices are overworked and impose strict time constraints on them to provide high quality service while maintaining efficiency, and this trade-off between high productivity and an in-depth understanding of or technical picture of an invention can jeopardize the quality of classification result. Thus, it can hinder accurate and constant classification. The following are also factors. First, with the development of education and science, the discrepancy between the code representing the curriculum and multidisciplinary skill can cause difference in code assignment, mainly due to different perception of the concept of function and application. With the development of law, the tradition of national IP laws and the development of a common legal framework can have a significant impact of the result of code assignment. In addition, even if patent offices share a common classification system, the concept of invention can be lost in the process of translation into other languages, and patent classification is not independent of the social context, so even the same patent examiner can derive in different classifications depending on different organization contexts or over time. Patent classification is also subject to temporal variation. The continuous emergence of new technologies lead to changes in the basic concept included in each code. Concept shifts. Here are some technology-related factors. Technological advances in database searching and information retrieval have brought about new changes in the way code are searched. This combined with the aid of finding appropriate codes and the availability of best database has led to the trend toward assigning more code to patent documents. Figure 2 shows the trend of the world top 3 patent office assigning more codes over the past several years. Additionally, factors that cause automation fails, such as spelling errors or printing errors, act as technical flaws that can reduce the accuracy of patent classifications. Artificial intelligence is the science of developing intelligent systems that can perform tasks that generally require human intelligence, and developing classification model is one of the main fields of AI. A variety of machine learning and deep learning algorithms can be utilized to build classifiers as shown below. Research-based patent classifiers are mainly based on supervised learning, and patent classifier can analyze various pictures extracted from patent documents. From an engineering perspective, this selected picture must be processed, and converted into an appropriate format that can be input to a classifier. Afterward, a single classifier or an ensemble of multiple classifiers is trained, and the output result of the classifier are ranked according to the probability value of the corresponding codes. However, this process entails several problems. Patent classifiers are affected by the specificity of patent classification itself and the lack of a training data set with higher accuracy, and this factor require special attention when developing a classification model. Accordingly, the author want to see whether the less AI technologies, especially deep learning and LLM, can solve some of the problems discussed in Chapter 2, despite their own strengths and weaknesses. Short texts are composed of dynamic vocabulary and long-tail vocabulary. Advanced in natural language processing, especially the use of large transformer-based pre-trained model and technique to adapt the output layer to smaller and more specific dataset can solve complex and diverse patent vocabulary problems. However, LLM may be limited by their learned vocabulary. Also, long-tail word tokens found in patent documents are difficult to properly represent in language model used in patent classifier, and the first step to deal with this and make prediction based on the limited number of samples is to preprocess the data before feeding it to the language model. Another approach is to take an existing LLM, fine-tune it for the patent classification text, and expand its vocabulary by adding new words from a specific corpus. The following patent document contain various information sources that can be used as signals by the patent classifier, and it is neither efficient nor effective to use a text picture for training. Therefore, we utilize picture engineering, which is a method to train the classifier using the most important word or process the word sequence using a full-length quantitative graph method, which is a transformer-based model. However, the attention mechanism of the transformer is computationally specific when dealing with long sequences despite its parallelizability. To solve this stage to adjust the LM in needed. In addition, an ensemble architecture consisting of multiple classifiers can be trained with different pictures, and their output can be appropriately combined to generate the final prediction. Next, the patent document consists of several difficult fields that must be filled out during the application process. The description is the longest part of the patent document and contains information about the invention and drawing, but the related technology or drawing description may contribute less to the patent classifications. Therefore, text segmentation technique can be used to automatically identify important subparts of the description, and recently research is being conducted to find semantically homogeneous part of patent document by applying headline or classification using machine learning and considering them as to segment and utilizing an unsupervised method. Finally, high-performance automatic classification systems are based on supervised learning and require large amount of high-quality correct data. Correct data labeled or assigned by human experts with inherently include subjectivity. Therefore, in order to build a high-quality learning dataset, it is important to secure collect data from patent office with high consistency and accuracy of patent classification by utilizing sampling techniques such as oversampling and undersampling. Specifically, human qualifier should manually review and modify the assigned codes by random sampling or when certain conditions are met. Caution: utilizing automated patent classifier will benefit many offset of patent classification work and make the daily work of patent examiner more efficient. One limitation of deep learning-based classifier is that their low interpretability, making it difficult to understand how the algorithm works and to identify the root cause when error occur. Therefore, automated patent classifier should provide patent examiner with detailed information about the proposed classification during the subsequent examination process. Additional improvements include: conclusion. The study facilitates the construction of a successful automated system for patent classification. For the future, it is predicted that AI technology can solve the essential difficulties of patent classification and gradually elevate the inconsistency existing in patent classification. For the future of patent classification, it is expected that experts with knowledge of not only patent classification procedure but also knowledge engineering method will be needed. It is also believed that patent classification will achieve a performance of more than 90% within the next 10 years. This concludes the review. Thank you.